Good morning. If you could grab a seat, we'll get started in just a few seconds. All right. Good morning. Can I get a great good morning? Great. Good morning. Thank you, sir. My name is Jonathan Cooper, the Innovative Learning Officer for the district, and it is my great pleasure to be here today to bring you in this morning to see this partnership of innovation, community, science, nature. Hopefully you'll be able to pull something away from today and be inspired. That's the idea, that you would be inspired to think about the possibilities for you. We've had students up here after each session talking about international studies, innovation, business possibilities in the future, how this technology will change our world forever. What you will see today is something that will definitely set a new pathway for innovation and technology. You'll see how technology is getting closer and closer to the authentic integration with humans and nature. It's amazing. So please don't take this for granted. This is an amazing opportunity for you to see it. If you're wanting to take pictures and tweet that out during the session, that's perfectly okay with me. Please don't let that be a distraction to others. But it is hashtag Mason Innovates if you are going to tag that to something or your Instagram. We have this great partnership with the city, so it is my great pleasure today to introduce Mayor David Nichols. Please give him a warm hand. Thank you.
Good morning. Now, let's see. What classes do we have out there this morning? Is this junior and seniors or seniors or what? We got. Well, I see I got that one right, didn't I? It's a real honor for me to be here today and what this represents. Because this wouldn't be happening today if it wasn't for the hard work of an awful lot of people, and there's a lesson in there for all of us. How many of you have seen the movie It's a Wonderful Life around Christmas time? Okay. One of the themes in that movie is how one life can impact and affect so many other lives. That's one of the themes I want you to take out of here today when you leave after this. But the other thing is something that's very important to me and why it ties in with the city. Because before I became mayor, I was a CEO of a publicly traded technology company. And one of the most valuable lessons we learned in doing that was to think out of the box, to challenge things. Somebody can tell you all the time, well, we've never done it that way. Why? Why? Just because someone hasn't done it a certain way doesn't mean you can't. Each one of you are so unique. You must remember that. Don't just accept things because it's been done that way. Think out of the box. And sometimes the most complex issues in life have the simplest answers. But we don't realize it. We don't take the time to think differently, to be different. And that's the beauty of it, particularly with innovation. Which brings us back to why we're here today. The city of Mason is very aggressive when going after companies to come here. And for any of you in this age group, you've seen a lot of growth in the city. And you'll see a lot of technology-based companies. That's not by accident. That's been by long-term design. And we look for companies that are innovative, that have a long-term bright future, but also want to give back to the community, which means us here today. Had this company not decided for their reasons, and for the city and the school systems, which are one of our biggest partners, all the way from the governor's office down to go after these type of companies, today wouldn't be happening. You all will not be leaving here, wouldn't be leaving here with some of the ideas you're going to have. And I want you to remember that, because it's part of the long-term plan of the city to move these kind of things forward to where you all can have these opportunities. You're the future. No telling how many people in this room will have so much impact on other people's lives in the future. You can determine that. But you got to think out of the box. challenge things all the time, constantly. It's good. And that's the one thing, if there's a theme message I want you to leave here today from me, and why I'm so excited about Festo being here, is they do that. They're one of the most innovative companies in the world. And they started some of the biggest innovations and impacts they've had by studying things just around them, taking a new approach. And they're going to talk about that. I'm going to let them do that. But think of it. And a lot of the technology they're going to present to you today isn't necessarily the technology as a result of whether you see something flying or doing this or that. It's what came from that technology, the impacts. I think they're going to tell you most everybody this morning, or at least throughout the day, are probably impacted by something that they provided to a manufacturer or service company. So take these kind of thoughts with you today. And I'm getting ready to introduce a lady that I have been so impressed with. I did not know her before too long. It's with Festo. By the way, has everybody seen the new Festo building up there off of 71 in Columbia? Along the interstate? That's Festo. Based out of Germany. But they'll have a couple hundred jobs here before too long. So, okay, I see some people shaking their heads. So, give out a salute next time you drive by because you'll get to know these folks a lot better. So, in fact, if you could, join me in giving Ms. Andrea Zemek a warm welcome, please.
Thank you so much. Good morning, everybody. How are you today? Good? Okay. So I'm here to talk to you a little bit about Festo. I won't bore you with it, I promise you. And then I'll go into a very unique R&D platform we have where we study nature to improve automation technology. Quickly about Festo, we are a provider of automation technology. That means anything in a factory that moves has our technology in it, okay? We have over 300,000 customers worldwide. So you can imagine that's a lot. We are in 176 countries. We had 2.34 billion euros in sale last year. So you can imagine we're a huge company. We have 17,000 employees worldwide, and we come out with 100 new innovations every single year, 100 new patents. And that's because we consider ourselves a learning company. We reinvest not only in R&D, but also in furthering our own employees when it comes to training and education. But it goes further. We also believe that you guys, in your education and your enthusiasm, because you guys are our future, not just for our industry, for the world. But imagine your future and what you can do. You can move mountains, and this is what I'm here to talk about. Okay, so as you know, we have the brand new facility here where we're looking to hire eventually 250 people. This facility is very important to us. It's our logistics center, and it will serve, as it already does, all of the US, all of Mexico, and all of Canada. So that is big. Our US headquarters are in Hub Hub, that's Long Island, New York, and we have some other locations in the US, but our biggest ones and what we're very proud of is New York, the headquarters, but especially here, Mason, and we're very happy to be here. And in a very short time, we've already figured out we made the perfect choice. We are in over 200 industry segments. I won't bore you with them, but I'm going to give you the largest ones that you're familiar with. As you can imagine, as I'm saying, 200 industry sectors. It means everything you're using, from your clothes on your back to the cars you drove here with or were driven, the toothbrush, toothpaste, lotions, shampoos, all of that stuff is made in factories using our technology. You just won't see it because it's inside those machines, okay? And so we're represented in automotive, water technology, biotech, pharma, food and beverage, chemicals, and mining, meaning oil and wastewater. We're pretty much everywhere. Again, I'm here to talk about our unique R&D platform, the Bionic Learning Network, where we identify interesting principles from nature, try to recreate them, study them, understand them, but always with the goal to apply it into automation to make automation better. Our Bionic Learning Network is a Festo initiative. We call our experts engineers, design engineers, mechanical, electric engineers. We have biologists, you name it, we have it. But it's a true collaboration with universities, institutions, design firms, private inventors, you name it. We collaborate with them. It is a truly joint effort. Why do we do that? It's because when you look on the left column, you see all these tasks that have to be performed in a factory. It's all about traveling, moving things linearly or without not linear, positioning, grabbing, grasping. And ironically, all of those tasks are performed by nature, by animals in nature. Only they've perfected it over millions of years through evolution. They're perfectly adapted to their environment. They're perfectly efficient. So there's a lot we can learn from nature to improve our own technology. And I encourage all of you to do the same. As you live your lives, as you go through your routines every day, if you see something, stop and question it. How does it work? Do you know how Velcro was invented? A man was walking, going on a hike, and he was brushing up against these thistles and bushes. And by the time he came back, he had all these bristles stuck in his pants. And they were stuck so good, because that's how nature made sure that the seeds would spread, that he couldn't remove them. He actually had to throw the pants out, and he was annoyed as you wouldn't believe. But as he pulled them out, he questioned it. He didn't just pull them out like you and I would normally. He looked at it and he studied and he's like, how is this possible for this tiny little thing to be stuck in my pants? And he noticed this tiny little hook. And while it really annoyed the life of him, the fact that he questioned it and took a closer look at it gave him this idea of, hey, how cool would it be to use this principle for an adhesive to stick things together? So then the next logical step was to create the loop to go with it. That is how Velcro was invented. Imagine how Velcro has changed your lives. Do you remember in kindergarten when you were glad you didn't have to tie your shoes anymore? That's made possible by that silly little bush. So I encourage you to look at the world around you very differently, just like our engineers do. To do that, we have two ways of doing it. One is the top-down process, and I'm going to give you a real-life example. A smartphone manufacturer came to us and asked us for a different and better way to grip smartphones. The conventional prongs weren't doing it because they would drop or they would scratch the phone. So for a long time we used vacuum technology, which is a Festo specialty pneumatics, anything to do with air pressure. However, when you use vacuum technology, it's not very precise, and the phones very often would drop much earlier than we wanted them to. Our engineers did not have the solution to this customer's problem. However, we did look to nature. And the first thing we looked at is the gecko, because we know a gecko can walk up glass panels very easily. We studied the paw of the gecko, noticed the skin of the gecko and these tiny little fibers that make it possible. It took us 2 years, but we were able to recreate the skin of the gecko synthetically. And now these smartphones, because of that, are being handled by this artificial gecko skin. And if you think about it, that is now energy-free. It's just a material that is tacky and non-tacky based on a principle from nature. So this is a real-life example where we had a problem and we were able to solve it. The other process is the bottom-up process. And that's where we find an interesting principle in nature that doesn't make sense when you first look at it. We question it, we study it, and then hope to be able to find an application for it in automation, and I'll give you an example of this. This is an example of what we call our fin gripper, our flexible gripper. This was our first project in the Bionic Learning Network in 2006 when we studied the fish. Again, we talk about animals being perfectly adapted to their environment. We realized that when you look at a fish fin, when you put pressure against it, it does not move into the direction of the pressure, it actually curls toward it. No matter what side the pressure comes from, it curls toward it. That was a very unique principle we discovered. And as we studied it, if you were to cut a fish fin in half, you would see these slats in the center that make this movement possible. And again, just the pressure is what makes it curve. So this resulted in a real life application that truly revolutionized automation. It comes in 2 and 3 fingers, and for the first time ever, we are now able to handle eggs, produce, and all in the same application because it literally wraps itself around the object. This can now, in the same application, pick up an egg, a light bulb, a sneaker, a water bottle. This was never done before, and so it's really something as simple as a fish bin has revolutionized our world in automation, and so that's a really amazing principle if you think about it. I'm going to talk to you about, so let's just quickly go back here. So what we do is we look at the natural principle, we recreate it technically, we then do the bionic adaptation, meaning the actual robot, but the goal is always to find an application for it in automation. Next, I'm going to show you a video of our flex-shaped gripper. This gripper is based on the tongue of a chameleon. Just imagine what it replaces, those 2-prong grippers, and what this can do by just studying this chameleon and its tongue, and all the different things it can pick up that was never possible before. This is making our finger obsolete. Okay, so did you see how this is truly revolutionizing that world of grippers once again? I mean, there are no limits to this type of gripping. In fact, we just came out with this prototype in April this year, and our customers went nuts over this because there are so many tiny little things or uniquely shaped items that right now cannot be gripped, like those glasses, coffee cups, spoons. All of that is not possible currently. So again, this is just a prototype. However, we had such an overwhelming response from our customers that we are now piloting this. And we're working with 15 of our largest customers to create grippers based on this for their specific applications. One of them is those juice boxes that you guys had as kids that come with the straws. Those straws were not, there was nothing that could move these straws and handle them. So we're working with them. But one of our best customers is right here. It's Procter & Gamble, and we're working with them with this gripper. So we're very proud of that. And again, think about how by the time you guys graduate, how our world will have changed and technology. Cars driving themselves, that is all around the corner. And imagine by the time you graduate college, how much the world has changed. And then think about your own careers and how you can contribute to change that world around you. Our engineers in the Bionic Learning Network focus on some topics that are most important to us. One of them is energy efficiency, also lightweight design, human and machine interaction. Earlier I had a student come up to me and say, how do you feel about machines replacing humans? That is not ever going to happen. However, machines will perform a lot of the mundane tasks like screwing things in all day long. You do that for 2 years, you have carpal tunnel, and you will not work much more in that field. Also, those are low-paying jobs. It's okay to eliminate those. However, the machines that we're building and creating and the technology will always require people designing them, creating them, working with them, and there's so much information now that we're going into the industrial Internet of Things that will have to be worked at. So what I'm saying to you is you will always have a job. However, the skills that are required by you will be different, and your wages will be different because you're no longer doing mundane work. And that's why it's so important for you guys to pay attention and to go into sciences. I'm not an engineer. I studied biology. I majored in biology. And I never thought for a million years that I'd be standing here talking to you guys. I thought I was going to go into genetic counseling and all of that. And you know, truth is, it took me years to find my passion in life, to know what I want to do. I never in a million years thought I'd be working for a company like Festo in automation technology. But here I am, because I'm using my background in technology, I'm using my passion, and you know what? All of us are affected by automation. We think it's just a factory and they're making things. Well, you're wearing those things. How much you're paying for those things, the quality of those items, and also the world around us when it comes to efficiency, when it comes to energy and a clean environment. It affects all of us. So these are the things that you can really do to make the world better. Communication and learning. Animals that learn about food sources and learn to communicate about them have a great advantage in nature. We believe the same is true for machines. Components that can talk to each other, communicate, hey, I'm broken or I'm out of parts so that there's less waste. There is a big advantage. Machine learning. All of this is going to be in your future. We already have prototypes of machines that have machine learning algorithm. All this artificial intelligence. And last but not least, function integration. Integrating as many functions as possible into just one component to make it happen. And I'm going to show you the Dragonfly when you see how tiny that is and you think about how much technology was crammed into this tiny little thing. But I know you guys are all here to see our robots, right? Yeah. So I'm going to first talk to you about our smart bird. Festo in 2011 was the first company ever to decipher bird flight. We were able to create a robot that flies exactly like a bird just by the flapping of its wings. It literally does not have any other drive mechanism. It is modeled after the herringull. It weighs less than a pound. I mean, look at this thing, 6-foot wingspan. It's made of carbon fiber and styrofoam to keep it as light as possible. And what took us 2 years to figure out is the movement of the wings, that they don't just go up and down, but if you look closely, they also tilt, and that's what creates the thrust and lift. And there is a lot of censoring in this bird because the wings have to be at a certain position and then react and tilt. So all the motors that make it go up and down and tilt have to work together and communicate together to make this bird fly. And that was our biggest challenge that took us 2 years to create, between the materials and the censoring and this artificial intelligence to make this bird fly the way it does. You guys want to see it? Yeah. I better hear a louder yes. Yeah. Much better, all right. So the pilots are going to bring out the real bird. They're going to put the battery in and it'll take a little bit. As you see this bird fly, you'll see that the direction of the head and tail is very important because that also determines the direction of the bird flight, just like in nature. It has a tiny little battery because it's all about weight ratio and it's very aerodynamic. We can't actually fly it in air conditioning a lot of times or outside when there's a lot of wind. Who here knows Coachella, the music festival? So last year this bird was at Coachella. And Marcus, one of the pilots, was cursing me every day because in the desert there was a lot of wind. So we thought many, many times this bird was going to land in palm trees. And I'm not kidding, right, Marcus? Yeah, he laughs now. He wasn't very happy last year. But it was a great experience. Okay, you ready? forgot we just fed it. Watch out, it might drop something on you. Story as I'm talking about our pilots who just arrived yesterday from Germany, Marcus Schaefer and Niels Schlemfer. Niels is just 18 years old and he's doing an internship and he just came from Germany to the US for the first time. What a cool job he has, don't you think? Isn't that really cool? Also, to just give you an idea, I was talking to you about my own career that I studied biology, didn't do anything with it for a couple of years because I didn't know what I wanted to do. And then finally, I found my passion. I'm going to tell you another story about Marcus, who shared with me that he actually was flying model airplanes with his dad when he was 6 years old. And since then, that was his passion, it's his hobby. And when he was a teenager, he had this dream one day, and he was like, wouldn't it be great if I could fly things for a living and take him to really cool places? And here he is at 30 years old. He is flying cool things in really cool places like Mason, Ohio, Coachella. He flies things in New York City for the Rockettes. He's working with David Copperfield, who you all know. He did the grand opening for the Winter Olympics in Korea. So guys, the sky's the limit, but start looking at things differently, question them. Don't be afraid to ask questions, and find something you're passionate about, and get a well-rounded education. Science, technology, look at where it led us. The sky is the limit. Imagine how the world is changing by the time you graduate and how much you're going to change it. But now I know you're here to see another robot, the Dragonfly, right? Let me talk a little bit about the Dragonfly. Do you know that the Dragonfly has not changed in 150 million years? That means it's perfected for what it's designed to do. So there's a lot we can learn from that. If you look at the Dragonfly, you learn that each wing is controlled separately, independent of the others. Each wing is controlled by 5 muscles in this tiny little insect that weighs next to nothing. And it's also controlled by 3 to 15 neurons. A dragonfly, technically speaking, can perform the tasks of an airplane, a glider, and a helicopter. That means it can go really fast and accelerate, slow down abruptly, can hover in midair, and it can fly in all different directions, sideways, forward, and backwards. So that's a pretty cool thing, and that was a big challenge for us. Once we had deciphered bird flight with a bird, which can only fly straight forward and, in whatever direction, our next challenge was to recreate the flight mechanisms and tasks of the Dragonfly. How did we do that? How did we replace the muscles and the neurons? This is our Dragonfly. The muscles are controlled by motors, and the neurons are translated into sensors. And again, a lot of intricate censoring is in that Dragonfly. It weighs only 6 ounces, so you can imagine how much technology we crammed into it. Are you ready to see it? Yes. All right. You better be louder than that. Come on, guys. Much better. All right. And by the way, later we invite you to come up and take a look at it as well if there's still time, and we'll also open it up to questions and answers, okay? This Dragonfly, by the way, 75% of it is 3D printed. See how it changes direction, hovers, deal for us to be able to create. There is one central brushless motor in the center, and then each wing is controlled by 2 servo motors that twist and go back and forth. And again, the sensoring is what makes this possible, and the sensoring is what translates into automation for condition monitoring. Yay! Okay, I know we don't have a lot of time, but I'd like to open it up to Q&A, and we're going to start by sections. We have Brian back here with a microphone. Any questions in this area? This is your chance. If not, I'll quiz you.
Not one question? Okay.
Okay, then we'll go to the middle. Any questions, guys? There's one in the front. I like when girls ask questions. Not that I don't like guy questions.
How do you guys use like computer intelligence and like that sort of thing? Do you have a problem with cybersecurity? Do you store your information on the cloud, or like what sort of programming basis? Do you have a language that you specialize in?
Great question, and I cannot answer it. But it's a great question. I don't know what they're doing on the German side. What I can, however, tell you is that it's become a really big topic on so many levels, especially with the industrial Internet of Things and what in Germany they call Industry 4.0. With all this communication out there, even what we're talking about here, and in automation, it is becoming a big issue. And it's something, again, this is an example where technology moves so fast that we often lag behind responding to some of the side effects, so to speak, like security. So that's a great question. But I don't know the language we're using. I know they always work on that. That's always a big topic internally, but I don't work with it per se. But I can find out for you if you want to come up later, if that's something. Any other questions? Okay, back there.
So would the applications of this technology be military?
If they were, they would probably drop M&Ms on you and you would have to duck. But no, it's a really great question. I'm glad you asked it. Thank you. Festo does not get involved with military or medical. And these Bionics are prototypes only. We do not sell them. And if this were, I mean, it took us so long to get the weight ratio right that you couldn't even put a camera or anything in it, it would go down just because it would weigh too much. So we do not get involved with that. These will never be sold or recreated. They're prototypes only. Thank you for asking that question. Anyone else? Maybe on that side, guys? Any questions? Okay.
Do you only sell to manufacturers?
We sell to manufacturers and we sell to machine builders because our technology very often is inside the machines that manufacturers have on the manufacturing floor. So a lot of that is that, and then we do a lot of customer solutions. Customer solutions, an example that I gave you is the NanoForce gripper, the Gecko. But another example for that would be where a manufacturer, and it was a smartphone manufacturer, there are these tiny little screws at the end of the phone that people were screwing in and you can barely see them. And they were inconsistent. So the customer asked us, can we do this by machine? And so now we created a solution to screw these tiny little screws in so the phone's not scratched, it's not overwound or underwound. And on the flip side, the person is not just sitting there doing this and having carpal tunnel after 2 years. So those are the things we'll do. But so mostly manufacturing and machine builders are the end user for our products. Great question, thank you. There's a question here at the front.
I was wondering how much it costs to make one of these with like design and then materials and all together.
I don't know a price. If you mean after we've already done the engineering just to recreate it, it probably would be maybe $20,000 to $30,000 for the materials because they are all handmade. So if I had to guess, $20,000 to $30,000 to recreate them. But it was in the millions for us to get to this point through the prototypes and all the trial and errors. But yeah, you could probably do it for maybe $20,000 if I had to guess. Thank you. Any other questions? We'll do one or two more questions. One more maybe.
Got somebody over here? Brian, see something?
When the Dragonfly was flying around, you were saying something about what it was made of. You were saying 75%, and you were sort of overwhelmed by the noise there.
Oh, I'm sorry. I'm glad you asked them. Thank you. 75% of this Dragonfly is 3D printed. The rest is carbon fiber for the wings, and that's because it's lightweight. It can be hollow as well to save on the weight. And it's flexible because a lot of it is how the wings react to the airflow, just like in real life with the Dragonfly. And then there's a very thin membrane. It's thinner than Glad wrap and more fragile than that, again, to keep the weight up. So, but yes, I said 75% 3D printed. I invite you guys to come up and take a look at these, talk to the pilots if you'd like. We do have a few more minutes. Thank you so much, guys. I hope you enjoyed it, and keep going. Good job.